Hey, good afternoon, folks. My name is Russ Hilley. We're going to be talking this afternoon about using contact in Femap. Appreciate you all joining us, taking some time out of your afternoon. And we're going to go ahead and get started. I think we have the majority of folks who responded. So with that, we're going to go ahead and get started. We'll say if you have any questions, you can put them into the chat box, and I will do my best at the end of the presentation to answer. And if there's something I can't answer on the fly, my contact info is at the end of the presentation as well. And I will definitely get back to you. You can email me with any questions you have. Just a little bit about the company. We've been around since 1997. Serving a variety of industries. A lot of the guys specialize in composites and developing strong, lightweight structures that are easy to manufacture. We provide low-level support through developing test plans and as well as advanced stress engineers from BS all the way up to PhD level guys. And we're located right outside of Washington, D.C. in Sterling, Virginia. Some of the programs we've worked for and some of our customers listed across the top, some aircraft. We've worked on some of the spacecraft. I know Jim, our company owner, headed up a good portion of the composite crew module program. We've worked on Orion, James Webb, and still working WFIRST telescope with Goddard as well. We have a couple of guys supporting that. Some of the partnerships we have is we are a Siemens Value-Added Reseller. We carry most of the Siemens products, Femap and NX Nastran right there at the top of the list. And we're going to be talking about that today as well as Fibersim and Solid Edge. We also provide training for these products as well. So if you are interested in training, we're also a Collier research reseller as well with the HyperSizer products. Okay, so I will go ahead and get started. This is going to be kind of a high-level basic discussion of contacts. So we're going to take a basic look at setting this up. First thing I'm going to do is, you know, everybody talks about, you know, I hear a lot of people call it glued contact and linear contact. So we're going to take a look at a couple of the differences there just briefly. We're going to go through an automatic creation of a contact pair. And we'll talk about some of the parameters in the contact property, the regions, and the connectors as well. And then I'm going to do a brief example of setting up bolt preload with contact. It's important to note that, you know, contact is needed for the use of bolt preload. Okay, so a few of the differences here are the features of each, and you know the webinar is not about glued connections, so we're not going to go too deep into that other than seeing what it looks like. As the name implies, the components are literally glued together. It does not have to be a coincident mesh or anything. It's going to work pretty much the same as creating a coincident mesh and merging the nodes. And I'm going to show you an example of both, just the results. In a glued connection, like we said, the components are basically glued together, welded, however you want to process that in your mind. They can't separate under any loading condition. As we'll see, I put an opposing load on both, and you'll be able to see that the components separate with the contact connections, and they cannot when you glue them together. The glued connections will constrain the parts to one another, so you can have your boundary conditions set up on one component and the other will be constrained to that with the glued connection. The glued connection also works across all solutions within Femap and NX Nastran, although the advanced nonlinear analyses treat it a little differently, and perhaps those types of things are the subject of a future webinar that we might do if we have enough interest. The linear contact is simply the parts can touch each other, cannot pass through, but they could separate. So if you put two components together, like I'm going to show you in just a minute, you'll see under the opposing load that one component can actually separate. Works well for bolt preload. I mentioned that a minute ago, and we're going to take a look at an example of the bolt preload. With contact, you have to constrain all rigid body motion in the model. So if you constrain this model we're going to look at in a minute, just on one end and try to make a contact, it's going to fail because of a pivot ratio error, and of course having unconstrained rigid body motion in the linear static analysis. So the linear contact works in the linear static and advanced nonlinear solutions. So you're not going to be able to use this with the basic nonlinear or a modal solution. Okay, so let's just jump into Femap. I have the results here. I think these slides will be distributed to everybody in attendance later, and you'll be able to refer back to this. But for now, let's just jump into Femap, and I have a little model here that I've set up and actually created a contact. You can see the region there and the connector between the two plates. I've constrained them on both ends just for simplicity here. And I just put a 100-pound total load pointing up and another one pointing down. And I ran this model. So just taking a look at the results. I have two results sets over here. And we'll see with the glued, remember I said this would constrain the model and the two components can't separate from one another. And if I had the right, I guess I ran this model backwards. Nothing like having to fix something real quick. So we'll just change this back to glued. This runs very quickly. So with the contact, you can see the two plates can separate from one another, and in the condition where they touch, you see the upper plate, pushes down. If we take a look at the glued connection, of course, and deform our model, you see those two components cannot separate from one another. And if I increase the deformation a little bit, you can see that the two components under both loads would remain together. Okay, so that's a little bit of difference. And if we take a look at the results, just to show you real quick, the max stress in this model, 1930 psi. And I did do a case where I went ahead and constrained the nodes just so you can see that the glued connection is going to give us the same result as creating a coincident mesh. And that's pretty much all we'll talk about with the glued and coincident mesh solutions. There's a webinar we have out there on assembly modeling that goes into a bit more detail about coincident mesh connections and glued connections. So if anybody needs to refer to that. So we have the results for each of our glued contact, our glued connection, I'm doing it too, and the linear contact. Okay, let's take a look at how to create a contact. The easiest way is to just use this connect automatic command, and I'll just go out and demo that in Femap. But just to give you the highlights here, we're going to select 2 solids to connect or more. We're going to select the options for face-to-face and contact, and then the tolerance, which again should be larger than your gap. So if you had a gap of 5 thousandths between your 2 components, you would want to make sure that tolerance is larger than that gap. You can define the contact using geometry before or after meshing. So you have that flexibility to use the geometry. Using the connect automatic, you're going to be forced to use geometry, whereas if we create our regions manually and create our connectors, which we'll see an example of that as well, then you'll be able to use element faces to create the regions. So geometry is not always required to use this feature. So let's go out and take a look at what that looks like. So I have a piece of geometry here. So the easy way to do this is to use the connect automatic, and it just again asks you to select the solids, and we're going to select face to face, and it defaults to a glued connection. So we'll just change that to contact, and then you could increase your tolerance if needed. These 2 components do touch each other, so we won't need to increase that. And you can see it creates the contact in there for you. Now, the other thing it does is it makes some assumptions as far as the connection property. It's going to use the default values for the connection property. So if I open that contact, then it's going to set up the max search distance. It's going to set up all these parameters, except if we hit this defaults button, it'll change the search tolerance, and we'll talk about that a little more in a few minutes. Okay, so the contact property assumes the default values when you use the connect automatic command, so that'll be created automatically, as well as the connector. So the connector will automatically be formed when you use the connect automatic command. And if we look at this, you can see it, if I had not changed it there, you can see it references the 2 regions we created and the contact property. Again, these can be defined on the fly as well if you want to define a region based on surfaces or elements, if you have elements in your model already. Okay, so we saw that just a minute ago, that the contact's now going to show up in the model info tree as as it's shown here. A nice thing to do is always to rename this. And if you want to keep up with the regions, they can be renamed as well. And you can keep up with what regions belong in what connection. And it makes your model easy to keep up with, and it makes your bookkeeping life easier. Okay, so the components of a contact, so the connection property. So we're going to go through and define some of this stuff on the fly here, and take a look at some of the parameters in each. But the connection property, it's going to allow you to define friction, search distance, and other parameters that we're going to hit the highlights of those as well. The connection region, you're going to need 2 regions per contact, a master and a slave region. And the connection region defines the faces, whether it's geometry or elements that are going to be considered in contact with one another or considered for contact. In this case, because your loading will determine the connection. The connector defines which 2 regions are considered in contact and the connection property to be used. So let's talk about the property. So I just said that the connector defines the two regions and the property. So the first point we can make here is unless you're using you have multiple friction values to be considered, you only need one connection, one contact property per analysis model. Now with glued connections, it will only consider one glued property per model. If you have 100 glued properties in there, it will use the first one. Not so with contact. It's probably another difference I should have highlighted. So define the connection property with the contact. There are multiple things that can be different. You could have a different search distance for connections. You could have different friction values as well, or you could include or not include shell thickness, the element offset, and so on. So you could have as many contact type properties as you need. So unless you have multiple friction values, usually you only need one contact per model. Okay, don't underestimate this defaults button and get caught up in all these other parameters in the model. 9 times out of 10, you know, if you create a new property, a new connection property, and my computer is moving a bit slow. I hope this is keeping up on the screen for everyone. 9 times out of 10, when you're creating a connection property, you can hit this defaults button and it will set up all of the default values here. These bottom ones are for glued parameters. We don't need to consider those at all. But the only thing I would recommend changing here is, and I'm not sure why Femap sets this to such a large value. I think there's only maybe 25 or 50 thousandths or something like that gap in here. There's not a big gap in between my two cylinders in this model. So I could reduce that search distance, and that with a large number of contacts, making that max search distance a more reasonable value will sometimes improve your runtime. So you can keep that in mind to set that max contact search distance to a reasonable value. And we hit OK, and we are ready to create regions and a connector. It will auto repeat the command unless you've got that set in your file preference to not do that. Okay. All right, defaults button. Changes to these remaining parameters are not often needed, but sometimes you do want to change them. The friction value, of course, just defines a coefficient of friction. It's a value we look up, you know, in a table between two materials in contact with one another usually. The minimum contact search distance is most often 0. This can be negative to consider an interference fit. So that's kind of a special case of doing a linear contact. The max search distance, I just mentioned that, should be larger than the distance between any two contact regions. If you have a gap between two regions that is 100 thousandths and your search distance is 50, it is not likely to find that connection. So again, the defaults will often set this to a large value for some reason, and you can go ahead and set that to a reasonable value, and it'll often help reduce your runtime with contact. Contact is going to add to your runtimes in NX Nastran, especially in large models. Okay, some of these other parameters, the max force iterations and max status, those two parameters can be increased to improve convergence. The initial penetration, again, things that are not often needed to be changed. but there's 3 settings in here: calculated, calculated 0, and 0 penetration. Calculated is based on the grids, and think about 2 meshed parts where you might have grids that come close or at least almost encroach into the other based on mesh resolution. That this setting takes that into account when determining the penetration. Calculated 0, it's pretty much the same, only if it's detected, it automatically sets it to 0. And 0 penetration, as the name implies, sets all the contact to 0 penetration. So the models I have set up today, except for one, but most of the things we're going to look at today deal with solid elements. But contact will work with shell elements, and will take into account the shell thickness. And I think I have the thickness set in here where, you know, they either barely touch or they're barely apart. So the contact is going to take into account the thickness of the shell elements, and it'll also take care of the Z offset of shell elements if you happen to have Z offsets in your shell property. Okay. All right. So when the connect automatic command region is used, regions are automatically detected and created from surfaces. So regions for contact can be manually created using surfaces or elements as well. So let's take a quick look at that. I'm going to go back to this geometry and just delete my connection entities over here. And let's take a look. Connection region, or the easy way, if we want to go to the model info tree and simply right click on connect on regions and hit connection region. And we have some options we can set, whether it's a deformable or rigid type, whether we're going to use, whether our output is going to be nodes, elements, or elements, no faces, or elements, as we're going to default to elements today. Nodes would be used if you are using an edge to face type connection. So today, and this one is going to be defined by surfaces. So if you see when I select a surface, it adds that to my list. I hit OK, and it creates one region up here in the tree for me. And I can continue the command and create another region, and we would be ready to set up our connection between these 2 components. Now you can create manual, if you have no geometry, we can create regions manually as well. So what we would like to do is create a region for each of these cylinders, so that when we put an enforced displacement on this upper cylinder and make contact with the second cylinder, that it's not gonna pass through. It's just gonna make the connection. So I'm gonna turn my shell element thickness off, and we're gonna go and create a region, a connection region here. And now the output's still gonna be elements, but we're gonna define by, instead of surfaces, we have no geometry in here. So we're gonna hit the elements here, and we're gonna add multiple, because we want to just create a region here. Now, one thing you could do is we could just create our region in the area of contact, and it might help our model a little bit, but in this case, it's a small model. But in large models, you would not want to define connection regions, you know, far away from the contact like this. So let's hit the Add Multiple button, and it's going to ask me to select a face. So I can select my face there, and pre that selection, you see Femap goes and selects the elements by adjacent faces. That is the default. You can change the tolerance for selecting those and it would allow you some flexibility in how those are selected. We hit OK, and you see it populates the selection here. Hit OK again, and we'll do the lower one as well while we're here. And we'll just go ahead and grab that and hit OK, and we have our regions connected for this model. Or they're not connected yet, but we have our connection regions set up for this model. Okay, so we can manually create regions using surfaces or elements. Okay, so we just showed this. We select the elements by using a face definition, and then Femap selects those based on adjacent faces. Okay, we also saw that we can create regions the same way using surfaces. Okay, so the last thing in the contact, in a linear contact, the components of an actual linear contact is the connector itself. So we can have as many regions, as many connectors as needed in a model. There's no limit to this. The only caution I have for you in that respect is, as I mentioned earlier, with the connection properties. So if you don't need a lot of connection properties or don't have different friction values, all connections can reference the same property. So when using contact, the slave or source region should have a equal or greater mesh density than the master, and this is for post-processing of things like contact pressures as well. Okay, and these also, I forgot to mention here, the regions and properties can be defined while on the fly. You could just sit here and hit, create a connector, hit define region, and define your master, define your slave, and then hit the button up here to define the property as well. Okay, let's take a look at creating a connector in this model we just were in. So we'll just create a new connector. And if we wanted to create a region, we would hit define region. It would have the same dialog. I'm going to cancel that since we have our two regions. We also have our connection property, but the new connection property. So in reality, you could start right here with just creating connectors and not create properties or regions ahead of time. I find that a lot of times just depends on the situation, what's easier. So we could hit the define new property button, and it would bring up the define connection property. We could, of course, hit the defaults button and keep going there, and it would automatically populate the property field. So if we have a connection property defined, so we will go ahead and grab that. It really won't matter here. You can select the regions off the screen, or you can select them from the list, and you hit OK, and it creates the connector for us and auto repeats the command. The connector is defined by this little symbol right here between the two components. Okay, let's take a look at some results. I've got this model already ran in here. So what we can do is we can just take a look at some of the results. I'm going to hit a contour plot there, and we will deform this, and you can see that the two components don't really pass through each other. I'll animate that a little bit, and you can see I'm going to turn on the shell thickness, and we'll see what this looks like. And you can see how the two parts contact one another. We can look at the stress values. We can look at, we will look at contact pressure real quick, and then we'll move on. we'll talk about contact force a little bit later. So you can see all the elements where pressure is created due to the contact. Okay. Okay, we took a look at some of the results there, and we're going to take another look at results here in a minute when we do our preload example. Okay, some of the common things that I've done in the past and seen others do in the past. Search distance. Improper search distances may prevent contacts from being found. I think I mentioned that a few minutes ago. Having a smaller search distance than the largest gap in your model may cause no contact. Regions with complex shapes are regions that turn a sharp corner, for example. And I did a quick example of this. I just created this, and I'll show you, a quick example of how not to create the regions or the less preferred method. So one of the things we can do as well in visualizing our connections and our regions is we can hit this, we can right click on any region and hit show expanded. This is an example of a region that would not be preferred. You would not, now if this was a nice swept curved surface and that was 3 surfaces, that would be fine. But really sharp changes in geometry like this are not preferred for connection regions. I have seen folks create regions like this and create a single connector between these two, and the results are just not as good as they could be. So what's preferred is to create additional regions on each component and then create a connector for those 2 regions, which we can show our master or our target region, and then right click and show our slave region, and that would be one connection. And then we would do another one for the horizontal surfaces where we would create a master and a slave region. And again, this is another case where if you wanted to take the time to do so, this is not a complex model, but this region could have been ended right outside the cube here, and it would be just fine to run like that. Okay, region directions. Just like elements, like shell elements have normal directions, regions also have normal directions, and they're going to follow that face selection, phase 1 and phase 2. And it is something you may have to update from time to time, but regions generally should oppose one another for connections. In my experience, that's always been the case anyway. So what I'm going to do is go up here to my highlighter in the tree and hit show normals. And if I right click and show my expanded region, you can see it'll show the normal vectors. So this is a good model check when you're doing connections. So we can show expanded and check our connection regions and make sure they are in the right direction. And it's pretty easy to change that. If you have one that is in the wrong direction, such as this, then we can right click on that and hit reverse, and it will reverse the direction of the region for us, and we'll have everything set up correctly. I'm going to turn that off now. Okay, so we've talked about the mistakes here, the regions. Let's go and talk about bolt preload. That is something that is quite often very useful. So I have a model set here, and I went ahead and meshed this model to save us a little bit of time. And what I'm going to do is set up a bolted connection between the top and bottom plates. And we're going to go ahead as well and set up our linear contact between the two plates. So let's take a look at that. So I'm going to go ahead and create my connection. I'm just going to do this on the fly this time to show you what I was talking about earlier. I'm just going to right click on connectors, say new, and I am going to hit the new connection property, and it's going to come up with our defined connection. It says contact. I'm going to go down here and remember that defaults button works quite well most of the time. Hit OK. Now I'm going to hit define region. I have to define a master region, and I'm going to go ahead and define it on surfaces. I only have one surface, so I can do that. I could have hit add multiple. If I had multiple surfaces in here, that would work. I'm going to define a second region on my upper plate, hit OK, and define that, hit OK. And we have our connection created. It created our property, our two regions, and our connector all in one. So what we need to do now is create some bolt elements, and bolt preload can be used on beams or bar elements. Unfortunately, you can't use that on something like a C-bush, but you can use it on beams and bars. Okay, so I have an API here, and I believe this ships with Femap, so you guys probably have it too. The hole-to-hole fastener, and this is, you know, one of the things someone might want to do if you had a lot of these to do is edit that API and make it where you can do multiple at the time and use the same property. What it does is it looks for curves at one interface, then the curves on the other one. Oops, let me hit undo there because I clicked one too many times creating that bolt. So I'll go meshing, hold the hole fastener. I'll try to get this right here. And you see what it does is it creates a rigid element and two rigid elements and a beam element in here. Hit OK. Go and grab the other side of the interface. Do that again. And we're going to have 4 bolts in here. And what we're going to do, it bases the shape of that beam element on the size of the hole. So these beam elements, I think this is a 1/4 inch hole. If you wanted to allow for a clearance fit in there, you would have to go and edit the property. Okay, so the beam elements are created, and what we need is a load set. So I have a load set created, and what we can do is right click and choose bolt preload as our load type. It brings up a dialog that's a little different. Now we can create bolt preload on regions and elements. Let me cancel this real quick and go and I'm going to turn off my solid property and my geometry. And I'm going to turn off my rigid elements. And we'll turn off our regions and connector as well right now. So I'll show you both ways real quick. To create a bolt preload region, we're going to just say create a bolt region, and we'll grab that. We'll grab those two and hit cancel. We have that bolt region there, and there's our. Actually, let's edit that and do one at a time. I think I just reset that and grab this one. Previous command, and we have 2 bolt regions there. I turn those on, you'll see those. And I'm going to go ahead and apply my bolt preload now. And now if I do this, the regions and the elements will be highlighted. We're just going to put 1,000-pound preload on these bolts. I'll grab the the bolt region there, hit OK. I will run that previous command and grab elements, and we'll do the same thing. So you can put a bolt preload on the elements or the regions, and it will work just the same. And I need to and let me fix that load real quick. I don't know why it's not selecting my region here. Oh, wants my, I'm getting a little tied up here. Okay, now it wants the region. I think that is 4. All right, sorry, I'm getting a little tied up here, so we will fix this real quick by just creating a new load definition here. We have okay. Let me do this kind of quickly here so that we can move along. And then we'll define our bolt preload. I somehow got tied up there, folks. That's my fault. We will just go back and create the bolt preload on elements and grab our bolt elements here. And there it'll create our bolt preload. So grab the solid property. I have the constraints created, and I have the rigid elements connecting the two. Let's create it, and well, I have an analysis set created. Let's make sure I have boundary conditions specified, and I do. And let's analyze that. Let's make sure it's active and analyze. It doesn't take a minute. And you can see this. And what I did last night is, see, I put 1,000 pounds in each bolt, and went back and checked to see if I could total up the results in this model to equal the 4,000 pounds when I looked at the contact pressure, and it did. So I'm going to turn that region off, and let's go ahead and take a look at the contact force in our model. So total contact force, and let's contour that one. And what I'll do is I will hide this solid, and you can see how it creates the contact force around each of the models. So you can look at the various aspects of what the contact is doing, such as the contact pressure and the contact force around each hole as well. And if we summed up all these nodes, we should come up with somewhere, well, it should come up with 4,000 pounds. Okay. All right. So the bolt preload, we showed that the contact has to be defined between the components because the bolt preload is essentially squeezing them together. We can use that hole-to-hole fastener for an API, but you're not required to do that. To do this, I did it because it creates 4 bolts pretty quickly, but you can create rigid elements and beam elements manually as well, or using any other method you have. And then you define the contact between the 2 components, just like we discussed earlier in the presentation, and either define the bolt regions or bolt preloads on the beam elements. If you define the bolt preload on the beam elements, it's going to automatically create regions. So yeah, I think one of the questions I see here is this exactly. You know, it really doesn't matter which way you do it. If you define the preload on the beam elements, it's going to create regions. If you create regions, you're going to select regions to define the load. I usually use the beam elements actually. So if I'm going to use bolt preload and contact, I just define it on the elements because I don't have that extra step. And it allows me just to create my load definition and automatically creates the regions. Okay, so we took a look at those results right there, the pressure, the contact force. Couple other references. This is that assembly webinar I mentioned that'll guide you through a little bit with glued connections. The commands reference in section 4 deals with the contact property. We do provide Femap training. We have a standard class that we teach in a couple of times a year when we're not all, you know, during normal times. I'll just leave it at that. And then we can do specialized training as well. So if you have a topic you're interested in, I mean, we can host you at our office or come on site with you and do specialized training or mentoring alongside. And I've recognized a few names that have been to our classes in the webinar today. So another resource, I think you can find this on Amazon or by going to Eric's website, learningfea.com. Eric, that's no longer Eric's email address. He used to work for SDA, and he wrote this book, Learning Femap. It's pretty easy to follow, and it's a good introduction to Femap. Our classes, again, these slides will be distributed. You can take a look at what our classes teach. You know, dates are kind of TBD right now because I think we've put on hold any in-person classes. We also have available a 30-day trial for Femap, and you can download that. If you have any problems with that, you can register for the trial. If you have any problems, here's my contact info. This is my direct phone number and my email. Our sales manager is Keith Brennan, and here's Keith's email and phone as well. If you should need pricing on software or training, Keith's always available to help you, or I will go between there and help you make sure you get what you need. So feel free to contact either one of us anytime. If you have questions after this webinar, I'm going to go through the questions here that have been typed in and see if I can answer them. If I can't, I would ask you to just send me an email and I'll get back with you as soon as I can. So let's see. I'd be interested in to understand how these analysis tools have been verified with experiments. Contact is much more difficult. What would be a simple contact? What I've done in the past is I set up very simple models that I can do hand calculations on, such as this, such as just two cubes in contact, and you can verify the contact forces and pressures using that. The hand calcs for bolt preloads or otherwise that can be used to check the Nastran model. Actually, I mean, you're going to enter the bolt preload. What you can check there is, as I did earlier. So if we, you know, I won't quite finish this off, but let me just show you a quick tool to use. Well, I don't know if you've ever used this data table. So I need to shrink this down a little bit. Now I'll unlock it, and we can check the Nastran model, make sure we're getting the output we require. List output results to data table. And what I'll do is just maybe you know, our force, I believe, is in the Y. So I'll just check T2 contact force and hit OK. And then I will select these nodes. Since the force is a nodal output, I'll select those nodes that are, I'll grab one more there so that we make sure we have the entire region. And then that'll populate the data table as well as a summary. And all this should add up to your preload. So that's one verification. I mean, all that column, if you pop that into Excel and sum that column up, it should add up to your preload. And if it doesn't, it's usually a mistake there. I've found this to be pretty reliable. Okay. I believe the coefficient of friction is a static value, but I would have to verify that. I'm pretty sure. And yeah, I think we talked about making the region smaller to help it run faster, like not using this entire surface. So if you had a large model, yes, it would absolutely make a difference in runtime to be able to create those manually and keep them closer to the area in contact rather than the full model. That way it doesn't have as much to write out. Okay, phase 1 and phase 2 for shell elements refers to the top face or bottom face of the element, and you would visualize that by doing what I showed earlier, by using the transparent highlight or just the show normals and show your region, show which direction your region is pointed. And if you needed to reverse that, you could do that in the same command. Now, when you mesh, if you're meshing surfaces, the normal directions for your elements are defined by the normal direction of your surface. Otherwise, you can also, if you have elements that are reverse normals, turn this off and just double click there, modify, update elements, and orient plate normal. First edge would allow you to select a group of elements and reverse the normal direction of those elements, or choose any other direction you need to there. So hopefully that answers your question. If you define the mesh, if you mesh the elements between the surfaces before defining the contact surfaces where the surfaces meet, will the contact surface effectively unmesh? No, it does not unmesh anything. The contact is defined either on the element faces or on the surfaces, and it would be meaning your elements have to be associative to the geometry. So why would you use a bolt region instead of applying to the element? I think I touched on that a little bit. And yeah, like I said, if it skips a step if you do that. It really does. So I would agree with that, especially if you have a lot of them to do. You would not have to go in here and create a bunch of regions. So yeah, I think that's a good point. And like I said, that's usually the way I do it anyway. Are you going to prepare a webinar about advanced nonlinear using contact? We can take that as something to do in the future. We have some guys who are experienced using the advanced nonlinear tools, both the Adena nonlinear solver, which is the advanced nonlinear solver solution 601 and 701, and then there is the Siemens alternative, which is the solution 401, 400, 401. It's the multi-step nonlinear. So we'll have to see if we can get that on the schedule. And I think Chris is on the call here, so we could do that. Setting up contact in a modal analysis. That's not something I wanted to show here today, but you can do what is called a pre-stiffened modal. And let me go back to this model, not that one, this one. And let me make sure my property is set back to contact this time, so we don't have any glitches. So what you would do in this case, and we won't run this, but we would set up a new static or a new normal modes analysis. And I kind of frown on demoing things like this on the fly because I haven't done it in a while. So try this. If it gives you problems, give me a call. We'll link up over the web. But what we can do is just create a new subcase, and we'll hit next here. And we are going to just define some boundary conditions and hit OK. And now we have a static subcase in here. And if we preview this input, we should see in here, yeah, stat sub. So it inserted a static subcase that is going to run before the modal. So I'm not going to run that today. If you have further questions about that, please do give me a call. And okay, process for using contact elements in NX Nastran. Similar, yeah. We define all this in Femap, which we're using NX Nastran for the solver in this case. So yes, it is the same. I'm not sure if you're talking about setting it up into NX CAE, which we have a guy on staff who can use that, but we are using NX Nastran to solve the problem here, and NX CAE would do that as well. Any suggestions for coefficient of friction between steel plates? No, that's a lookup. You just textbooks and web searches there would be your best bet there. I don't have anything right off the top of my head. Let's see, is there a good way to model contact for modal? I just talked about that. Modal analysis only takes glue connect, it's linear. Yeah, okay. For bolt preload, is it better to use a single beam element for the bolt? Keith, I've never tried to use multiple, but I think it gets a little trickier using multiple beam elements for something like maybe a double shear joint or something like that. So, more literature about the subject. There is out here, if you go there's a lot of documentation that comes with Femap. You can go out here to the Simcenter Nastran. There is, let's see, handbook. I thought there was one that deals with dynamic other. So the release guide, the quick reference guide would show you, you know, what all the fields are in Nastran. So you could look in there. Let's see, the release guide, the Nastran user guide would probably be a good resource for that. And then the advanced nonlinear analyses are manuals as well if you're interested in that. So hopefully that answered your question. I don't have any quick references on, you know, textbook type literature on there. So, all right, we're a couple of minutes over the hour. Like I said, if anyone has any questions, please, I know Chris will be distributing the slides. I'll send those over to him as soon as we drop the call. And I know he'll be distributing those. And if you have any questions, please feel free to email me. I know many of you online that I've talked to before are our customers, and I'm always glad to help, try to answer questions when I can, or find a resource that can answer when I can't. So, and any sales needs or pricing needs, please contact Keith, or I can put you in touch with him as well. All right, thank you again for joining us. I hope we made the most of your time, and I hope to see you again on the next webinar. I hope everybody has a great day.